Welcome students. Here we are going to see how to draw the histograms. Construct and interpret the histogram with unequal class intervals. Before, we have already seen how to draw a frequency diagram, how to rearrange the equations, how to calculate the area of an rectangle. Now first of all, I want to notice that we have seen what the bar chart is and the histogram is, that is frequency diagram, which is defined for the histogram. In this first diagram, the bars has been denoted with the green color, and in second one the orange color has been used to define the histogram. There is the difference between both bar chart and the frequency distribution. That is, first, in frequency diagram there are no gaps. That's why this is called as histogram. Here the horizontal axis has been continuous scale. That means histogram is defined for continuous frequency distributions. If our variable is continuous in nature, then we can represent the frequency distribution for class intervals with the help of histogram. Where if our variable is discrete in nature, we can define the bar chart as the graphical tool. Here the width of bar is full width of class intervals. Width of bar defines width of class intervals. If we are having equal class intervals, the bar width is also going to be having equal one. Now we will see if your class intervals are of unequal size, then can we use this histogram? First of all, area of bar represents the frequency, right? Hence, we have to define different bars for the different class width. That is, sometimes the data collected will vary very little in the class intervals. Hence, we have to change the class intervals, so the width of class intervals is not going to be same. That is, survey was conducted to find the edges of surface. This is the example we are going to define. So here this is the table for this survey was conducted to find edges of 60 surface, which are defined in age group 0 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 40, 40 to 70. Here if you see the class intervals, the width is not same. First interval has width 15, second, third, fourth interval has width 5, fourth class having width 10, and the last class is having width 30. Okay, here we can see that there is no equal class width. Hence, for this also we are able to define the histogram. Now we will see how to define the histogram. First of all, frequency density to show height of the bar, right? Frequency density is used to show the height of the bar, where frequency is nothing but the area of bar. That is, width of bar is nothing but class width. Just look at this rectangle. This rectangle is used as one single bar. Okay, so length of this bar is nothing but the frequency density, and width of this bar is nothing but the class width. Hence, total area, which is defined in the orange color, is nothing but the frequency itself. So as per the area of rectangle is defined with the length into width. Similarly, frequency, which is area, can be defined as frequency density into class width. That is, if I want to define frequency density, we have to rearrange this equation. That is, frequency density can be equated with frequency divided by class width. Frequency density means the length of that bar we have to, or we supposed to, calculate. Just go for it. Here we have to define the histogram for following data. The same data set I have. Okay, then you just have to define the class width and frequency density. Class width for each classes, it will be, for first it will be 15, For second it will be 5. Third it will be 5. How to calculate the class width? Upper limit minus lower limit. That is 30 minus 25. It will be 5. 40 minus 30. It will be 10. 70 minus 30. It will be 30. As class width is not equal, that's why we are looking how to define the histogram. Now frequency density is going to be 5 divided by 15, that is frequency divided by class width, that will be frequency density. Similarly, 15 divided by 5 will be 3, 10 divided by 5 will be 2, 8 divided by 5 will be 1.6, 12 divided by 10 will be 1.2, and 10 divided by 30 will be frequency density. Now with the help of frequency density, we are supposed to define the histogram. As the graph is concerned, on x-axis we have to consider the age, and on y-axis we have to consider the number of frequency. All these years, that is age factor, is scaled from 0 to 10, 10 to 20, 20, 30, 30, 40, 40 to 50, like that. These are the scale we have. Now frequency density, the maximum one is 3. That's why we have taken 0 to 1, 1 to 2, 2 to 3. The 3 is the maximum height. That's why on y-axis we have measured only up to 3. So first one, the frequency density will be 1 by 3 and the class width from 0 to 15. So red one starting with 0 to 15. 15 point is between 10 to 20. So this much area has been covered. 1 by 3. That's why 0 to 1 में 3 में divide किया, and then just mark have taken with the first bar. Second bar will be for 3, and the width will be 15 to 20. That is from 15 to 20 we have measured up to 3. So this one is the second bar. Third one is 20 to 25 with the height 2. Third bar will be for 20 to 25 to 30, which will be 1.6. Again 1.6 has been made, and similarly 30 to 40 it is 1.2. Again the height of 1.2 has been measured and made the bar up to that. And the last one is for 40 to 70 with the height 1.3. Now this colored bar is defined for this given example, which is called histogram. So from this histogram we can interpret and find out the further answers also. For example, we have to estimate how many people between age 35 to 55 will serve. That is, we have to make 35, that is 30 to 40, in between 35 and 55. 55 will be from 50 to 60. Just consider, we have to identify the area of the graphs which this applies. Okay, so 35 will be here, 55 will be here. The colored area is to be estimated. Okay, so remember the frequency is nothing but area of that bar, and we have to find out the area of separate bars. That means that both the bars we are defining having certain different area, so that it will be defined as, first, this bar is having length and width such as 5 and 1.2. 1.2 height हो गया, 5 is width. Therefore frequency, that is area, will be 5 into 1.2, which will be 6. And for second bar it will be considered as 15 and height will be 1 by 3. So this will be 15 into 1 by 3 is 5. So estimated frequency, total area under these two bars is going to be 6 plus 5, and hence answer will be 11. That is, we can say the total ages of 35 to 55 number will be 11. Similarly, we can define the histograms for these examples also. Here the temperature has been given, 10 to 11, 11 to 12, 12 to 15, 15 to 16, 16 to 17, 17 to 20. and frequencies are also been given. Now here we have to define the class interval, that is class width, which is defined as 1 1 3 1 1 3, that is 11 minus 10 will be 1. Similarly 15 minus 12 it will be 3, and same part we have already calculated. So as per this all class intervals we have to define the frequency density also. It will be 5 divided by 1 is 5, 7 divided by 1 will be 7, 18 divided by 3 will be 6, 4 divided by 1 will be 4, 3 divided by 1 will be 3, 6 divided by 3 will be 2. Then as per this frequency and the class intervals we have to make the histograms, which will be defined as this one. Here temperature taken on x-axis and frequency density taken on y-axis. Similarly they have made all the histograms like this. 10 to 11 it will be 5, when 12 to 12, 11 to 12 it will be 7, then 12 to 15 it will be 6, then 15 to 16 it will be 4, and likewise. So this is what your histogram for given example. Similar one we can define for the next. So height in centimeter, frequency and class intervals. Height is defined with 151 to 153, 153 to 154, 154 to 155, 155 to 159, 159 to 160. Along with each classes, frequency has been given. So first of all we need to define the class intervals, which are again unequal. It is given as 2 1 1 4 1, and the class frequency, that is frequency density, can be calculated as 64 divided by 2, 43 divided by 1, and likewise. Similarly the graphs can be defined on x-axis, height will be there, frequency density has to be taken on y-axis, and likewise according to our class intervals we have to make the graph which are equal to frequency density, and they are shown in the figure like this. Same examples we have to consider. Just go through it. There are 4 classes from 0 to 8, 9 to 12, 12 to 15, 15 to 20. Class intervals has been defined as 8, 4, 3, 5. Likewise with the same example, with the same formula we have to define frequency density, which will be 9, 21, 18 and 7. Again the same histograms has to be defined. On x-axis we have to define time, on y-axis we have to define frequency density, and all the bars has to be made with the proportionate height of frequency density like this. Go for the next one. Class intervals has been calculated. As per class intervals and frequency given, we can define the frequency density. It will be 51.3, 51 divided by 3, 36 divided by 2, 12 divided by 1, 20 divided by 3, like that. And the histogram is made like this. The height of each bar is proportionate or is equivalent to the frequency density, where width of